Today's topic is transitions. Now, they seem pretty simple, but this is actually one of the more complex components that we can create with the Rocket Workbench, and I'll explain a little bit about what makes them so complex. So we'll start by creating a transition. Okay, so here we have, in this case, the shape is a cone, and it has an aft radius and a forward radius, which are different. So it'll allow you to transition from one body tube size to another. Now on its own, it's not too useful like this. Typically you will have it with shoulders, for example. And like the nose cone, some basic parameters. The shoulder has a length and a radius. But in this case, we have shoulders at both the front and the back. Okay. Now conical transitions are the most common, but let's look at some other shapes. So we have all of the shapes that are supported by nose cone, and that includes the cone that you see here, elliptical shapes, ogive, parabola, which again is a power series of coefficient 0.5, parabolic series, power series, the von Karman, which is a hack series with coefficient of 0. And of course, the hack series is the same, but we can change the shape a little bit. So this is the LD hack, which the LV hack, which maximizes the volume for a given drag. Okay, now the way we draw these transitions is what makes it difficult. Okay, so if we look at the way it's drawn now, if we have a transition with a rear radius and a fore radius, okay, the simplest way to draw it, which is what we've done here, is to use the minimum radius as our axis and then draw the half curve based on that. So if we look at the parabola, for example, because that is what we have in the graph, okay, and we'll look at it from the front. Okay, so you see it's actually fairly rounded towards the front of the nose of the transition. Okay, but that's not the only way we can draw it. So bringing our diagram back, we can actually do a clipped version. And in this case, we have the curve going all the way from the maximum radius, passing through the minimum radius, and then extending through until y equals 0. Okay, so your axis for drawing is the the y equals 0 axis instead of the y equals 10. Okay, now the way we find this intersect point is just by doing some searching internally to make sure that we match up with the fore radius. Okay. If we look at how that gets applied to the transition, all we have to do is select this clipped variable, and you can see that the shape actually changes. Without it being clipped, we have a more rounded curve near the fore of the transition, and with the clipped, it's a lot smoother into that fore and will actually terminate somewhere around here. Okay. Now, this doesn't make sense for all transition types. For example, the ogive. Okay, if we look at how that would be drawn, we can see that using the y equals 10 axis as the basis for drawing produces exactly the same curve as if we extend that along the y equals 0 axis. Okay, so in cases like that, we don't have clipped enabled. So another case where that would be true would be the cone. Okay, but where we can, we do present that as an option. We select clipped, and we have our nose cone. Okay, so which matches your needs? You can, check or uncheck and see which shape is most useful for your design. Okay. Some of the other parameters are the same. So for example, the forward shoulder and the aft shoulder are very similar to what we have with the nose cone, except one applies to the forward portion of the transition and one applies to the aft portion. Now we have the same styles that we have for nose cones. So we have solid, hollow, If we go to our model, we can see that it is in fact hollow inside. And as we spin it around, we can see all the way through. Okay. So we have capped, which is hollow but with caps on either end. So if we look at the cross section, and looking from the front is the best way to see that, you can see that we actually have a hollow center. But we do have an additional type, and that's called solid core. So it's mostly solid, but we do have a core diameter cut through the center of the transition. Okay, and we can specify the radius for the core here. Okay, now if we look at that in cross section, so we'll look at it from the front again, and I'll just maximize. And you can see we just have a simple hollow portion going right down the center of the transition. So for example, if you're designing a boat tail, you might omit the forward shoulder. And then you have a portion where you can put a body tube inside of that transition. So it acts as both a transition and a centering ring. And you can specify the diameter so that it will, nearly match the nozzle diameter of your rocket. And that's transitions.